All right, everyone. So last video we talked about LAN, local area network, and the previous two videos, and then we also touched base of internet as a physical connection. Now we're going to talk about Wi-Fi, that's wireless connection. Who have never heard of this word Wi-Fi? Tell me about it. And if you look at this diagram very well, you can even see like a map, the world map with different countries, everything we can communicate. But what is Wi-Fi, wireless connection? Do you even know Wi-Fi stands for wireless connection? All right. So Wi-Fi is a wireless networking technology that allows devices like computers, smartphones, tablets to connect to a network without physical cables. Unlike internet where you have to physically connect your cable, Wi-Fi, it happens wirelessly. You don't need that physical connection. It uses radio waves to transmit and receive data between devices and access points. What are your access points? You have routers, you have wireless hubs, you have switches, and we will see that shortly. In some of the other video, you guys, you will see like a switch. Remember, I don't know if it's this one. We can quickly go there. Do you see? Access point. But now we are talking about wireless, so we won't be seeing all this physical connection. So you have this switch or this router or this hub. As I said, we're going to define that or we discuss them like in depth in subsequent slides. But this is what is referred to access point, and you have all these devices that we've mentioned, not necessarily laptops, printers, smartphones, IoT, other devices connected to, you know, they say transmit and receive data between devices and access point. That's like also access point, but that happened with the use of radio waves that we will discuss in that. This is a typical example. If you guys see the internet cable, the physical location, no, but this all happen over Wi-Fi's, and these are all the things that we just mentioned. This is an access point. If you look at this access point, stuff they are being connected to each other, and then communication now happen over Wi-Fi. That's over the internet. And as I said, we will discuss on this in depth. Let's look at the radio waves. Radio waves. Radio waves are a type of electromagnetic wave that is used in Wi-Fi technology to transmit data between devices and a router or wireless access point. Do you see? So it's used to transmit data between devices, but this happen again wirelessly or even the access point. I'm going to see because those access point, you have all the assets connected to that access point. And of course, communication still have to happen, right? Has to happen. And that's why we said that, this occur in the form of radio waves. And I'm very intrigued with this particular image because I don't know this exact subject why schooling in my secondary school days. I know with this touch base on electromagnetic spectrum, we talk of all this gamma, infrared light, visible light. I have no idea what they meant, but I recall studying this in my secondary school days. And now it makes sense. Okay. That I have to teach this, it really makes sense. And that's why if you look at all this length, we have the long wavelength, we have the short wavelength, and with the long wavelength, we can see what falls under the long wavelength. We can see what falls under the short wavelength. And we look at the radio waves, we have the different speeds in and the units. And then if you look here, you could say, long wavelength, you see how long this thing is. Do you see the wavelength, right? Why for a short wavelength, you see how short is it? We talk of ultraviolet as well as gamma rays. Why for this, we definitely be talking about, this other type, the infrared and the rest. But to delve into this, let's see how transmission occur. And that's why I have it, the transmission process. First, we'll talk more about modulation, modulating the data of signaling coding or signal coding. Right, we're going to read the slide and discuss it. it says data such as files, website, or video streams. That reminds me, if you go to a playlist, start GRC in minute or your GRC in minute, I already have a video on what constitute data. You need to be able to understand what data are. We don't just be talking like that because everything again, data form the backbone of everything. Everything centers around data. And that's why it's important for you all to have a good understanding of that, right? And we say data such as files, website, or video streams need to be transmitted in a way that it can travel over radio waves, right? Remember, now we are talking of wireless, right? It doesn't even matter. Need to be transmitted over radio waves. The data is encoded into radio signals. We're going to see that through the process called modulation. So in modulation, this is a process of varying a carrier signal, that's the radio waves, right? The radio waves, in order to encode data. The data can be encoded by, have you guys heard of FM radio and AM, right? Now we are making sense. So it can be encoded by changing the amplitude modulation, that's AM, or the frequency modulation known as FM. That's why you hear the name AM and FM. But talking about amplitude modulation, now we start talking about the strength of the signal, right? The strength of that signal, or pretty much the carrier signal, which is the radio wave, the wave, right? And then when we're talking about frequency, frequency has to do with how often the wave oscillate, the oscillation, like kind of related to speed, but not really the meaning, but it talk of like the frequency, right? Talking about the wave oscillation. Why? The next one we'll talk about phase. Phase has to do with the shifts in waves, and we're going to define all of those. When it shifts, we now we'll be talking more about binary, because in computer world we're talking about 1 and 0, so we're talking about the binary numbers, and we will see that shortly. But in Wi-Fi communication, the radio signal carrying data is modulated. It's modulated to carry packets. The other word, packets of information. When we start talking about the computer world, now we start talking about packets, right? Network packets. Everything is being transmitted, carried about, delivered. Is network packets before you even receive the actual data. It doesn't matter which route it takes. It doesn't matter which devices it has to pass through. So we start talking about network packets. Okay? This encoding allows computers, smartphones, and routers to send and receive data using the radio waves. So I hope this makes sense. And as I said, for routers, what else did I mention? Maybe switches or whatever the access point, we will discuss it in subsequent slides. A typical example. This is exactly what we just covered, right? We talk about data. It doesn't matter what form of data it could be sound, anything. It's transmitted over radio waves. The data is encoded into radio signal through the process called modulation, which varied a carrier signal known as a radio wave. And when we go to AM, do you see it has to do with the strength of that carrier signal, the strength of that radio wave. While frequency talk about the oscillation, right? The frequency. And we're going to see that again with a good pictorial our visualization. You all can see, the diagram that or image that I provided. And then talking about phase at wave cover, it talk about the shifts in the carrier signal or the radio wave. Okay, so this again, first it says in Wi-Fi, data needs to be converted into radio waves for transmission. This is called, I think this is just a repetition, but that's fine. Let's just go over it. This is called modulation. This is how modulation comes to play. Modulation is a process of altering a basic, the other way you alter basic radio waves called carrier signal right here. These are the carrier signal, and this is the modulation. Now we start talking about AM, FM, or phase, right? To encode data which can be received and decoded by devices like smartphones, laptops, and routers. Carrier signal. What's a carrier signal? This is the basic radio wave that will carry the data. This is it. So it carries the data. That's why you hear the word carrier signal. It carries the data while modulation altered that radio waves. It altered it to encode the data before you could receive it. And once you are receiving, before you could decode it, but it altered it to encode the data, right? And that's why I said it is constant frequency and amplitude. So with the carrier wave, it is constant. It is static. So it has a constant frequency and amplitude. It has a constant AM and FM. Then modulation comes in now, process that alters the carrier signal to encode that data. There are different ways to encode a signal, right? And we have just touched all three types. This is a typical example. If you have this carrier signal that carries the information, it could be like whatever thing is it, it is constant, it is static as far as it is constant, that is the AM and the FM. But when it goes to the process of modulation, modulation has to alter it. So when there's that altering, occurs, then we start deciding, is it AM, is it FM, or is it phase? And I believe the next slide has something to tell us. There we go. Type of modulation techniques, right? In amplitude or AM modulation, the strength or amplitude of the radio wave is varied to encode the data. How it works, do you see? And remember earlier I said we start talking about binary, 0 and 1. Computer where they communicate in binary, in a binary format. As a matter of fact, we'll talk about IP addresses, but I don't think I'm going to show you boy how you can write, develop, create an IP address and all those things. I'm not going to, if I have some time, but I'm not so sure, right? I'm just going to give people, what I know is going to help you broaden your cybersecurity knowledge and to understand some of these basic concepts, right? How it works, the carrier wave's amplitude is adjusted based on the data being transmitted. Do you see? For example, a 1 might be represented by a stronger signal, while a 0 is represented by a weaker signal. Tell me about it. Have you gone somewhere else? Like, you know what? My phone, I have just one bar or network. I don't have connection. This is exactly what we are talking about, right? Do you hear the word? 1, stronger signal. 0 has to do with a weaker signal. And let's go to the next slide. First, they say think of an old-fashioned AM radio. If you turn into a station, you are essentially listening to radio waves where the amplitude of the signal changes to carry the sound. Do you see? That's a strength. The amplitude, the AM, it will change to carry that sound. That way you can listen in case voice or music. Have you been in a place where you want to do like shh, like, oh, got some form of like, crooked sound? This is exactly what we are talking about. So the amplitude, again, as I said, it alters the carrier signal. Again, it will alter it where it said listening to the radio waves where the amplitude of the signal changes to carry the sound. So it changes to carry that sound. And if it comes now, which is a 1, that's a strong, is a stronger signal. Everything seems very clear. You can listen carefully. But if it's a 0, it's a weaker signal. That's where you kind of hear some form of, a phony sound, right? They say Wi-Fi example. A Wi-Fi router, as I said, we're going to talk about router in depth, in subsequent videos or slides. Router could use AM. Router is an access point, could use AM to send data by increasing or decreasing the strength of the signal. based on whether the data being sent is a 1 or a 0. Remember, router, we'll go the router is also an interesting, concept. Do you see? So a router could use AM to send data by increasing or decreasing the strength of sending that thing. And it will all depend based on the signal, how strong in the signal. If it's a 1, then we know, of course, it increases. But if it's a 0, then we know that it decreases, right? For example, suppose a Wi-Fi signal is carrying the message 1010. The amplitude of the wave changes based on whether it's a 1 or a 0. And you see 1 equals to strong signal, 0 equals to weak signal. 1 actually signify higher amplitudes, while 0 signify lower amplitude. And we can see the example here, signal against time. And it tells you if it's a 1, when the AM is altering the carrier signal, it will tell you based on how strong that signal is. I hope you people are feeling me. Let's talk about FM, frequency modulation. The frequency of the carrier wave is altered also to encode the data. But how does it work? The carrier waves frequency, how often it oscillates per second. If you look right here, you will see something higher, like, oh boy, all right? You see, it oscillates. How often it oscillates per second, it is adjusted. A higher frequency is a higher frequency could represent a 1, and a lower frequency present as 0. So do you see? Do you see the higher frequency? But if you look at a 0, do you see? That shows you, of course, there is a weak signal. And this covers what we've discussed so far. If you look at the radio waves, right, you have 1, which is a higher frequency, or right here, higher frequency. And if you look at this one, do you see 0, lower frequency? And you have an FM radio. Again, remember, we're talking about wireless connection, Wi-Fi. Then let's talk about phase modulation. In phase modulation, the phase, that's the point in the circle, a point in the circle of the carrier waves is shifted to represent data. Once it is a shift, it represents data. But how does it work? The phase is a part of the wave that determines the timing of its oscillation by changing when the wave peaks or valleys occur. It phase, data can be encoded. For example, one phase shift could represent 1, and the other phase shift could represent a 0. Still, the concept of binary, and this simply tells us how it works. Once there's a shift, it tells us, it's a shift in phase represent data, and still 1 represent a change when it shifts now to 0, as our slide show, represent a change in data that needs to be encoded. And I believe this covers everything that we want to know about how they call modulation. They say, think about a wave that repeats itself in circle, like the hands of a clock ticking. If the hands shift in a specific way at a certain times, it represents different information. In phase modulation, the joint or the point at which the waves changes. Do you see? Here, no phase shift. But do you hear? You see? 1 equals to phase shift 0, no phase shift. It's adjusted to send data. Somebody. So Wi-Fi example, in Wi-Fi, the router could send data by shifting the phase of the signal, right? This phase shift are used to present 1 or 0, and that's something that we have covered already. An example to understand all 3 techniques that we've discussed The strength, that's talking about AM, that's amplitude modulation. The strength of the radio signal changes with each bit, with 1 equals to strong signal, that's higher amplitude, and 0 equals to 0 weaker signal, that's lower amplitude. But to have a visual example, they say imagine a wave where the height, that's the amplitude, increases and decreases as it transmits the data that we've covered. And likewise, this also speak in terms of frequency, where 1 again represent a higher frequency and 0 represent a lower frequency. And this, we talk about oscillation per second as it increases or decreases while data is being transmitted. And likewise, it shifts, a specific time where 1 equals to a shift occurs and 0, no shift has occurred. And to sum everything up, this diagram literally explains all what we have discussed, still with amplitude or AM, frequency modulation or phase modulation. And I have two different diagrams, literally, um, same concept. Likewise, with amplitude, it goes, we talk about the stronger signal as well as the weaker signal. In terms of frequency, higher frequency, low frequency, or a shift at a specific point in time, or no shift has occurred. But you might ask, how do Wi-Fi use modulation to transmit data, right? Wi-Fi routers and devices. Remember, routers was just at a basic level, we said that it's an access point, use modulation to encode and decode data. So when you access a website or stream a video, your device send a request to the Wi-Fi router. Do you see? When you visit a website, stream a video, your own device will send a request to the Wi-Fi router, right? The router then modulates the data into radio signal, which is sent out to the device. The device demodulates the signal, decoding, not encode. It has to decode because you got to read it. The data to the web page file or stream that you requested. Pretty much when you guys go to YouTube and you're watching this video, I hope you can relate. Now you have a background as to what happens, correct? If not, you can do some more research. So when your computer is streaming a video, the video file is broken down into smaller packets. Remember, I do all network packets. Each of these packets is modulated using AM, FM, or phase modulation into a radio signal that is transmitted over the air. So your computer receives the signal, demodulate, decode them, and reconstruct the video for your playback. And this is going to make sense when we go to OSI model. As I promised you people, I'm doing all this because I know we're going to hit there. We're going to touch all the different layers and we'll see how communication happens. This is, again, I went a little bit out scope, but I felt the need to put this information that way you guys can have at least a basic knowledge and just to understand how things happens, okay? Again, how Wi-Fi uses modulation data. This is something that we've covered again through the carrier signal or radio waveline, and then it's been encoded and it's been decoded. But some of the key differences between AM and FM in terms of what is modulated, we talk about strength, we talk about frequency, how often the wave oscillates, right? Signal quality, this is prone to, AM is prone to noise and interference, static distortion, while FM better resistant to interference and noise. And any good student will want to do some more research. Why are we comparing this? Why are we making this claim? Right? What of bandwidth? Narrower bandwidth used for AM radio, wider bandwidth used for FM radio. Power consumption generally require less power to transmit, require more power to transmit. Usage, FM radio, two-way communication, FM radio, television, audio, highly quality audio. Sound quality, lower sound quality, more static, but higher sound quality, clearer sound. While for range, longer range, but more prone to interference. Longer range, but more prone to interference, while shorter range, but higher clarity as well as quality. So with that, we've covered, a basic about Wi-Fi. I hope you guys learned something. I'm saying so because, again, we were going through switches. We've been covering a lot, but I felt the need for us to at least have a background knowledge and understand how the things work, okay? So I'll see you all in the next video where we'll be talking about switches and we'll also define some keywords.